Welcome to Sotantra education. In this lecture, we are going to discuss about the concept of wrapper class. Now, before moving to the concept of wrapper class, let us consider a scenario. Suppose your friend is getting married and she invited you to her marriage. So, then you buy a gift from the market. So, consider this is a gift, suppose anything, this is a toy or teddy you buy from the market. Like this, you buy a teddy from the market and cover it with the gift wrappers, or you can say special blue, black or green covers are there to pack a gift. So, for that you cover this with some blue, black or any color gift covers. Then write your name here. Suppose on that cover you write your name. Generally people write in red color. So, from and your name you have written, and with this gift you attend your friend's marriage. Now, assume that due to some unavoidable circumstances or any some other reason you could not buy the gift. Then in that scenario you decide to give 500 rupees. So, it is here this 500 rupees to your friend in her wedding. So, instead of giving this teddy, you are going to give this 500 rupees to your friend in her wedding. So, generally what we will do? So, instead of giving this 500 rupees like this, you buy a cover to pack the money. So, like this. So, this type of covers are there to cover a money. This type of covers are there to gift some money in a wedding function or birthday function, like that. So, you for that you buy a cover like this and pack the 500 rupees inside this, or put this 500 rupees inside this cover, and you hand over this cover to your friend at the wedding venue. Or you can write here similar to the previous one, we can write your name like from this and hand over this cover to your friend in her wedding. So, here you can note that the money, we cover the money and give it as a gift in your friend's wedding. But in regular or day to day transaction, we give the money without covering for faster transaction. Suppose you purchase something from the market, then generally we take 500 rupees like this from our purse, then give it to the shopkeeper like this. At that time we do not cover this 500 rupees and provide it to the shopkeeper. So, why we give directly like this to a shopkeeper, or why we use such type of denominations without cover in day to day transaction? Because to achieve faster transaction. Similarly, in Java there are 8 primitive types for faster execution of the code. So, what are these 8 primitive types? So, I think you are aware of these 8 primitive types. So, these are byte, short, int, long, char, float and double, and another one is boolean. So, these are 8 primitive types available in Java for faster execution of the code. And if we treat these things, these primitive types as objects, then the program is going to take a long time unnecessarily for execution. So, for efficiency of the program, these primitive data types are provided, but in some situations it is required that instead of these primitive types we should use the objects that represent these primitive types. Like consider the situation, suppose we want to pass a primitive type by reference to a method, then that is not possible. So, in that situation we need objects to pass as a reference. Now, another example you can consider, like many standard data structures operate on objects. So, in that situations we cannot use these data structures to store the primitive types, because these data structures support only objects. We cannot use primitive types there. So, despite the performance benefit offered by the primitive types, there are times when you will need an object representation, and to handle this situation, Java provides type wrappers which converts one primitive types to its equivalent object, or we can say these wrapper classes encapsulate a primitive type within an object. Or similar to the previous example, like this cover wraps the rupees, and we can give this rupees as a gift in a wedding function. Similarly, here these primitive types like char, byte, short, int, long, float, double, boolean are covered or are converted to objects, or we can say we wrap these primitive types into an object, and the corresponding class is called as wrapper class. Or we can say a wrapper class is a class whose object wraps or contains a primitive type, contains a primitive data type. So, like here as it is written, you can observe a wrapper class is used to convert the primitive types into objects or reference types. So, we have 8 primitive types and the corresponding wrapper classes are there. So, for char you can see the corresponding wrapper class is character. For byte the corresponding wrapper class is byte. Similarly, for int the corresponding wrapper class is integer. For long this is long, for float this is float, like this. So, here you can observe the primitive types and corresponding wrapper class. So, except this character and int, so let me highlight this. So, this one is character and int. So, except this character and int, all the wrapper classes we are getting by just converting the first letter of the primitive type to capital. So, here you can observe. So, it is float. So, just make this F as capital F and we are getting the wrapper class. Similarly, double. So, make this D as capital D and we are getting the corresponding wrapper class. So, except character and int, all the wrapper classes are the all the wrapper classes we get by converting the first letter to an uppercase letter. So, as we have 8 primitive data types, so Java provides 8 different wrapper classes, and these wrapper classes are defined in Java lang package. So inside this package java.lang, these wrapper classes are defined. So now here you can see, we know that object is the superclass of all the classes. Now we have another class number, that is a subclass of the class object, and the numeric wrapper classes like double, float, long, integer, short, byte are subclasses of the number class. So this, from this figure you can see this one. So number is a subclass of the object class, and these numeric wrapper classes like double, float, long, integer, short, byte. So these are the subclasses of the number class. Now we have another interface, that is comparable. So comparable is an interface, and here you can observe all the wrapper classes implements this comparable interface. So here you can see dot line represents this one. So double, it implements the comparable interface, float, it implements the comparable interface, long, integer, short, byte and character boolean also implements this comparable interface, but this character and boolean wrapper class are not the subclasses of the number class. So as the numeric wrapper classes are the subclasses of the number class, the methods that are defined in the number class are available here, are available in the numeric wrapper classes, and the methods that are defined in the comparable interface are also implemented here, all these wrapper classes. So first we will discuss about the number class. So in number class some methods are there. So one is byte value method. So byte value returns the byte, or the return type of byte value method is byte. So byte value is the name of the method and the return type of byte value is byte. And what is the role of this method? This method converts the calling object into byte value. And what are the allowable calling objects? So the calling objects can be an object of byte, short, integer, long, float or double class. So if one object from these classes call this byte value, then this method is going to convert that object into its corresponding byte value. Now similarly another methods that are defined in the number class are short value. So what is the role of the short value? It converts the calling object into short value. So here the name is short value and return type is short. Similarly we have another method int value. So int value converts the calling object into int value. So your return type is int and the name of the method is int value. Similarly we have another method that is long value. So that converts the calling object to long. Similarly float value, double value. So we will see the examples of this method short value, int value, long value while we implement a program on this. So these methods are defined in number class. As the numeric wrapper classes are the subclasses of the number class, like we have discussed. So these byte value, short value, int value, long value, float value, double value. So these methods are also available in these numeric wrapper classes like int, double, float, long, byte, short. Okay, so now all these methods are available, like we have discussed, all these methods are available to byte, short, integer, long, float and double class. So because these methods, these byte, short, integer, long, float and double class are the subclasses of the number class, and as these methods are defined in the number class, these methods are available in its subclasses also. Now move to the character class. So we have one character wrapper class. So this character wrapper class wraps a value of the primitive type char. So this character wrapper class converts or wraps a primitive type char to character object, and it has only one constructor, that is character char ch. Suppose we want to write like this, or we want to create a new character object. So we can write like this, character obj equal to new character. Suppose character value is a, so I am taking one character, that is a. So this C is capital and this C is also capital. So character obj equal to new character a. So here a is one character, and this obj is going to store the character object a. So in this way we can convert this character a to one object of type character, and this is the constructor. Okay, so what are the methods that are available in the character class? So these are char value. So here this char is the return type and char value is the method, and another one is compare to method. So it is going to return one int type or int value. So int compare to character obj. Suppose if you write like this, obj1 dot compare to inside bracket we write suppose obj2. Now if obj1 less than obj2, so it is going to return a negative value. So it is going to return a negative value. If obj1 greater than obj2, so it is going to return a positive value. Now if obj1 equal to obj2, then it is going to return 0. So like this we can use the compare to method. Similarly, static character value of, so here the return type is character object and the method is value of. So it is going to take one character as parameter and convert that into one character object. Similarly, we have another method, that is static boolean is digit character ch. So this is the return type boolean and the name of the method is digit, and it is going to take a character parameter. So if the parameter is digit, so it is going to return true. If the parameter is a non-digit, then it is going to return false, because here return type is boolean. So this method is going to return either true or false. Similarly, the methods is letter, is uppercase, is lowercase, to uppercase, to lowercase are there. So is uppercase, is lowercase returns a boolean value. That means if the parameter is an uppercase character, it is going to return true, otherwise it is going to return false. Similarly, is lowercase returns true if this parameter is a lowercase character, otherwise it is going to return false. Similarly, this to uppercase converts one input character to the uppercase. Suppose if you write to upper case, suppose small a, then it is going to return capital A. That means it converts this input parameter to capital character or uppercase character. Similarly, lowercase. So these are the methods that are available in character class, and these are some important methods. Some other methods are also there, and we will see the implementation by writing some program. Okay. So now the next one is byte class. So the byte class wraps a value of the primitive type byte in an object, or you can say this byte class converts one primitive type byte to an object, and it has two constructor. One is byte number, another one is byte string str. So here we can write like this, like byte obj equal to new byte. Suppose if we write 5, then it is okay. So it is going to convert this 5 into an object, or we can write like this, byte obj equal to new byte, and if this one is a string, then also it is going to convert this string into one object. So as this can be represented as an object, so it is going to convert. So if I write byte obj equal to new byte java inside, so if I write byte obj equal to new byte, then here in this string part I write java, then it is not allowed. So such type of string java is not allowed. So only the number values you can write here as a string. Now this byte class has also some predefined methods like compare to, that is also there in the character class, because compare to method is present in the comparable interface. So this one, in this interface the compare to method is there. So all the wrapper classes have the method compare to. So the byte class has also compare to method. So it is going to compare between two byte objects and returns 0, positive or negative depending on the comparison, like we have discussed earlier in the character class. Similarly, another one is byte parse byte string str. So here the return type is byte and the name of the method is parse byte, and it is going to take a string and convert this string parameter to a byte value. And another method is string to string. So to string method, it just converts the byte object into a string value. So this to string method is defined in the object class. So as all the wrapper classes are the subclasses of the object class, so this to string method is there or is available in these wrapper classes. Then another method is value of. So it is going to return a byte object and it is taking one string parameter and returns or converts that string to byte object. And another is value of byte b. So by taking one byte parameter and it converts that into byte. Similarly, we have sort class. So another wrapper class is sort. So it converts the primitive type sort into the object, and it has also two constructors like we have discussed earlier. So you can take either string or a sort value. Now some important methods that are defined in the sort class are like this. So compare to, parse sort, to string, sort value, like this. So these are some methods, and some other methods are also there. Similarly, we have integer class. So integer class wraps a value of the primitive type int in an object. So here you can observe it has two constructors. one is integer int num, another one is integer string str. So if we write integer obj equal to new integer, suppose 25. So it is going to convert this 25 into an object of class integer. Now another way is like this. So we can write integer obj equal to new integer. So this can be a string 25 like this. So in this way also we can write, and so these two constructors are allowed in integer class. And similarly some methods are defined in the integer class. So these methods are already we have discussed in the previous wrapper classes, like compare to. So it is going to compare two integer values and it is going to return 0 or positive value or negative value as a result, and here the return type is int. Similarly parseInt method, and it is going to take one string parameter and convert that to int value. Similarly toString method, then value of method. So this value of method takes a string parameter and convert this to integer object. Now int value, we have another method. So this int value converts the object into int primitive type, or converts the object to primitive type. Similarly string to binary string. So here the method name is to binary string and the return type is string. So it is going to convert the integer value to a binary string, and because it takes one integer value int I as parameter and returns the string type of that integer value. Similarly another method to hex string, to octal string, like this. So these are some integer some methods that are defined in the integer class we have discussed here, and some other methods are also there, and we have kept only the important methods. So similar to the integer class, we have another class, that is long. So this long class wraps a value of the primitive type long in an object, and it has also two constructors, one is long num, another one is string str. So it can take either a long value and it can take either a string value as a parameter and convert this into the objects. And some methods that are defined in the long class are like this: compare to string, parse long, value of. So these methods we have already discussed in the previous classes. So here the approach is same. Now another one is float class. So the float class wraps a value of the primitive type float in an object, or we can say this float class is used to convert a primitive type float into an object, and it has three constructors. One is float num we can take, or we can say the parameter here can be float, can be double, can be string. So previously only string and the corresponding primitive type was there. So here we have one extra parameter, that is double. Now some important methods that are defined in the float class are like this. Then move to the double class. So the double class wraps the value of the primitive type double in an object, and it has two constructors, one is double, another one is string str. So double num, double string str. And the methods that are defined in the double class are like this: compare to, equals, to string, value of, parse double, like this. So we will see the implementation of these methods and implement some programs on this. Then the next one is Boolean class. So here The boolean class wraps the value of the primitive type boolean in an object, and it has also two constructors. One is boolean value, another one is string str. That means the parameter can be a boolean or can be a string. Now some methods that are defined in the boolean class are like this: compare to, equals, to string, value of, and parse boolean. So now we will discuss about the boxing and unboxing. So converting a primitive value to a wrapper object is called boxing. So boxing means the procedure of converting a primitive value to wrapper object. So that is boxing, and the reverse one is unboxing. That means converting a wrapper object to a primitive value is called unboxing. So now we are going to discuss how we convert a primitive value to a wrapper object, like we have discussed earlier. So this one, integer int object equal to new integer 2. So here 2 is one primitive value or primitive int value, and int object is a wrapper object that contains the primitive int value 2. So in this way we can convert this primitive value or primitive int value to an object of integer. Now this statement and this next statement, this one, so are equivalent. These two statements are equivalent. So either you can write like this or you can write like this. So you can remove this new integer and inside parenthesis 2 you can simply write 2. So if you write integer int object 2, then the compiler can understand that we are going to convert this primitive value 2 into a wrapper object. So this step is called as boxing. So like we have discussed, this one is called as boxing, and this one is called as auto boxing. That means the compiler automatically understand this one and convert this 2 to a wrapper object. So I hope this one auto boxing is clear. Similarly we have auto unboxing. Let us see the example here. So we have one int array, and this int array is of type integer. So integer int array 1 2 3 we are writing. So just give this, it is missing, so curly braces. So curly braces is missing. So integer int array 1 2 3, and here we are just writing the primitive value 1 2 3. So this one is an example of auto boxing. So these primitive objects 1 2 3 are converted into the integer objects. So the primitive values 1 2 3 are converted into objects of type integer. Now if you write println int array of 0 plus int array of 1 plus int array of 2, so here this is called as auto unboxing. So here these integer objects are converted into primitive values, and their sum gets printed, or we can say 6 gets printed on the screen. So this statement is an example of auto unboxing, or we can say this statement is an example of unboxing, and as compiler does this automatically, so it is called as auto unboxing, because we are not writing the complete procedure. Now this one we can see integer int array. So here the primitive values 1 2 3 are converted into integer objects. This is boxing, but here as we are not writing new integer like that, and we are just writing the primitive types, so compiler does this automatically. So this is called as auto boxing. So I hope this auto boxing and auto unboxing is clear, and boxing and unboxing is clear. So now we will write a program and see all the methods, or see all the implementation of the methods that we have discussed in the integer class, or we can say in the wrapper class integer. So first create one object using the constructor. So integer obj1 equal to new integer. Then here we can either take a string or numeric value. So let it be a value, suppose it is 30. Okay. So now we can create another object using the method like integer obj2 equal to integer dot value of, because we have one method value of, and using that method we can also convert one string to an object. So let it be 35. Okay. So now we have another method that is compare to. So let us write int a, because compare to results the integer values, that is either positive, negative or 0. So you can write obj1 dot compare to obj2 where obj1 and obj2 are objects of the wrapper class integer. So now let us print the value of a. System dot out dot println a. Okay, so let us execute this. So you can write java c test dot java. So it is showing one warning, so you can just ignore that warning. Then we can write java test. So it is showing -1 because here the obj1 value is less than the obj2 value, that's why it is printing -1, that means a negative value. Now we have another method, that is to binary string. So we can write like this. So system, okay, so just we can simply write here inside this a, we can write integer dot to binary string, and we can pass the value, suppose 5. Okay. So now let us see how this binary string method works. Okay, it is showing the warning due to this one, so just remove this one. Okay, so for this we are getting the warning. Okay, so it is successfully compiled, you can just ignore the warning. So it is showing 101 because it is converting this 5 to its equivalent binary string. Now suppose we can use another method, that is suppose auto boxing. So here instead of obj1 equal to new integer 30, so simply we can write obj1 equal to 30. So with the concept of auto boxing, this 30 is getting converted to the object of wrapper class integer. So now just compare this one and print the value of a like we have written. So let us check whether it is working or not. Successfully compiled, no error. So it is showing -1. That means this auto boxing works correctly. So similarly you can check all the methods that we have discussed in the wrapper classes.